Dear friends, today you are going to enjoy MOOCs with Gaurav Singh on the evolutionary history of horse that is divided into a few parts and 4 modules. The record of evolution of horse is well documented and known for its completeness. Fossil record provides the best known evolutionary series among all the invertebrates and vertebrates and was first studied about more than hundreds of years ago by a pioneer Russian paleontologist Vladimir Kovalevsky. Basing his studies on the European fossil genera, he concluded that EOHIPPUS, Anchitherium, Hipparion and EQUUS formed a line of descent and was a brilliant approach. Although his conclusion has been substantiated by later research, the forms he had at the disposal actually proved to be offshoots from the principal evolutionary events that occurred in North America. Major part of the evolution took place in North America, from where remains of horses have been found in great abundance in the floodplain deposits. Fossil remains comprising skull, fragments, jaws and isolated teeth, limb bones and other skeletal remains are known from strata ranging from early Eocene to Pleistocene. Many genera and species are good index fossils and are rare and useful in age determination of rocks which enclose them. Equine evolution is essentially a straight line evolution or orthogenesis. In other words, only little variation can be accounted. Almost a linear trajectory is usually identified from Hyracotherium to modern horses. It must be therefore emphasized that the horse disappeared in Pleistocene as a result of cold climate in North America, and which was its evolutionary home, but it migrated to Eurasia before it became extinct. Present-day horse seen in North America was reintroduced from the Old World, although the history proper has its beginning in a genus called as Hyracotherium, which is called formerly as EOHIPPUS. These forms themselves are credited with being descendants of an extinct old order known as the Condylarthra, which flourished during the earliest epochs of Tertiary, the Paleocene. Condylarth genera Phenocodus in the particular shows evidence of the probable ancestry to Hyracotherium, although it was anything but horse-like in appearance. Smaller than the smallest pony, these animals had 5 toes on each foot. Each toe is being provided with small hoof. Probably they walked on the soles of their feet, not on the toes as do the horses. Since no intermediate exists between the Phenocodus and Hyracotherium, however, the proposed relationship still remains conjectural. In contrast, there are a few problems over a lack of intermediates in the horse family itself. The earliest representative of stock, that is Hyracotherium, occurred throughout both North America and Eurasia during the Eocene epoch, more than 50 million years ago. In fact, this genus has not been reported from the late Paleocene of Wyoming, where rocks of the epoch form a series of strata totaling 3,500 feet in thickness. Members of this genus also were far from being horse-like in appearance and in structure. They are about the size of a fox terrier, with relatively short legs. On each forefoot or 4 toes were present, whereas on the hind foot, the toes in each toe was provided with a small hoof, one each foot. However, digit 3 was larger than the others, suggesting that they all bore greater proportion of the weight. A comparative study of the horse foot by C.L. Clamp and N. Smith 1942 concludes that the foot of Hyracotherium must have been supported by a pad much like those of such forest dwelling ungulates as the tapir. Furthermore, the muzzle was not elongate. the eyes having been located near the middle of the skull length. The molars had short crowns, prolonged roots and cusps like human teeth of this type. Hence, it is believed that the mammals were browsers, feeding on the succulent shrubs and other soft vegetation. They probably escaped the predators of the times by concealing themselves in the bush of the forest in which they seem to have lived, rather than by running as do their plains-dwelling descendants. The brain too, while quite unhorse-like, was relatively simple. Beyond this early level in the equine evolution, a great many representative types exist, but it is not necessary to discuss each of them in turn. Instead, attention may be focused on the trends of the changes that occurred. These various trends in the necessarily proceed at the same rate, nor have the directions, because much branching and side specializations are found at all the levels, even when they are not mentioned further in the foregoing account. Perhaps the most dramatic, if not the most important series of changes is found in the feet and limbs, which slowly become perfected as an adaptive or for fleetness in the evading predators. In the proceeding forward or upward through the time sequence or the fossils, one notices that the limbs become increasingly longer in proportion to body size. Actually, the lengthening was confined mostly to lower, that is distal bones, and the upper ones, that is humerus and femur, remain comparatively short. The evolutionary trends that characterize the equine evolution through Cenozoic era are as follows. Number 1, increase in size. Number 2, lengthening of legs and feet. Number 3, reduction in lateral toes with an emphasis on the middle one. Number 4, molarization of premolars. Number 5, increase in height or the crown of cheek teeth. Number 6, progressive complication of enamel pattern on crown surface. Number 7, lengthening of the face in front of the eyes from accommodation of high crown cheek teeth. That is Eocene horse. There was a warm and moist climate with a lot of vegetation. The first horses belonged to early Eocene, that is genus Hyracotherium, known from North America. The contemporaneous horses known from Europe were assigned to genus EOHIPPUS. In the early Eocene, horses were widespread and throughout North America and Europe, and probably within Asia as well. It has been suggested by the end of the early Eocene time, North America and Europe were once again separated by a water barrier. Hyracotherium became extinct in the Old World, and the evolution of horses was limited to the North American continent. All the horses that appeared subsequently in other regions of Eurasia and South America were immigrants from North America. Hyracotherium EOHIPPUS, it was a browsing animal with about 11 inches of height, that is approximately the size of cat, having arched flexible back with a long face, which was not elongated in front of the eyes as we do get in the modern horses. There were 4 functional toes in front and 3 in the hindfoot. In addition, the animal had a primitive skull with low crown cheek teeth represented by premolars and molars. None of the premolars were molariform. Cusp pattern with the crown was simple with a few cross lobes. Coming to Orohippus, it is known from the mid-Eocene strata of North America, whose last or the 4th premolar was molariform, which was a character that makes it more advanced over Hyracotherium. Next is Eohippus. Eohippus is known from the late Eocene strata and was slightly larger than Hyracotherium and the Orohippus. There is an evidence of an increase in the length of middle toe and was tendency of reduction of side toes. 4th toe was in the process of disappearance. 3rd and 4th premolar was molariform. Oligocene horses. Oligocene was a time of marked aridity due to large continental uplift, a few streams were left and the horses were to run faster for survival to get food. They have therefore acquired an evolutionary character along this line, ultimately leading to three-toed horses during Oligocene. The horse Mesohippus. Mesohippus lived during the early and mid Oligocene and was a smaller than sheep, having three functional toes in both front and hind foot. The cheek teeth was still crowned. Then Miohippus. Miohippus lived during mid and late Oligocene and attained the size of a sheep. There were three toes in each foot and the growth of the middle one went faster. Skull was elongated and eyes were situated more posteriorly. Three premolar were molariform and cheek teeth were still low crowned. That is Miocene horses. Due to uplift of rocky mountains in North America, lot of fine sand and silt was deposited in floodplain. At that time, grasses were expanding and were siliceous. Horses of that time acquired characters in responses to the siliceous grasses. Cement was added for the first time and first true hypsodont horses appeared in late Miocene. More complicated enamel pattern on crown surface was developed. Grazing horses appeared in Miocene. Then comes the Parahippus. Parahippus is known from early and middle Miocene and was very much like Miohippus in general appearance. Cement was added for the first time to the teeth. Middle toe was elongated, side toes far above the ground. Lengthening of the crown, all the premolars became molariform and the skull was more elongated. There was a further connection of the cross lobes in the crown. Then is Mesohippus. Mesohippus slightly increased in size over Parahippus but was much similar to it. It was first true hypsodont horse. Low pattern on the crown was much like modern horse. Protocone was just touching the main body of the tooth. It was three-toed horse. Side toes were far above the ground. It was functionally one-toed horse. Then comes the Hippohippus. It was the horse that evolved from an Anchitherium ancestry in the beginning of the mid-Miocene. It reached Eurasia where it survived for a short term in Miocene. It was large and heavy in build. Teeth were still low crowned. Side toes were relatively heavy. Pliocene horses. There were stretches of the grasslands in the North America and grazing horses appeared in large numbers. New land bridges across where none had existed for ages and great faunal changes were recorded. Then comes the Hipparion. It was a grazing horse with a long skull. Hipparion was a three-toed horse but functionally one-toed. Teeth had a complicated enamel pattern. Protocone was separated from the main body of the teeth. Hipparion invaded from Eurasia to North America. Next is Pliohippus. Pliohippus was much like modern horses in appearance. In the beginning of the Pliocene, an advanced species of Mesohippus gave rise to Pliohippus, in which side toes were missing. It was a true one-toed horse. Low pattern on the crown surface was very much like of that modern horses. Protocone was connected with the main body tooth. Near the end of the Pliocene, when North and South America were again connected by land after 74 million years of separation, Pliohippus migrated to South America where it gave rise to the Hipparion. In early Pleistocene, Hipparion became extinct in South America. Then comes the EQUUS. It represents the latest stage of evolution. It appeared in late or at the base of the Pleistocene in North America and Europe. EQUUS is a one-toed horse where the side toes were reduced to node-like structure which are covered by skin. EQUUS became extinct in North America in Pleistocene but migrated to Eurasia before it became extinct. that is the evolution of brain. Since the browsing animals can feed on vegetation at normal eye level, an elongation or elongated muzzle is of the little advantage to them, but to grazers feeding on heavy grasses with the head close to the ground have a high location of eyes on the head, but would hold distinct selectively advantage in watching for approaching predators. Among such early grazing horses as MESOHIPPUS, the muzzle had already elongated somewhat so that the eye was noticed behind the middle of the skull length. Later, this trend progressed rapidly so that the in the EQUUS, the eyes had reached the location approximately at the posterior third of the skull. The changes that have occurred in the equine brain structure are less thoroughly documented, but the trends in general that agrees with those of the other sequences as well. Earlier, the brain of the Hyracotherium had been described as being extremely primitive, like that of the opossum, which is a smooth fissure and having the less. However, there is no sound basis to believe that. A later study, that is Redinsky 1976, shows that the brain have been smaller so that the cerebrum did not cover the anterior portion of the cerebellum as in modern horses. However, it had three fissures that characterizes OLIGOCENE and MESOHIPPUS. The cerebrum and of the member of former genus was smaller or similar in structure, but was somewhat larger than the MESOHIPPUS. The brain had increased considerably in the extent so that it covers much of the anterior cerebrum. Although the longitudinal fissures were still relatively unchanged, the frontal lobe was enlarged and complexly folded, trends furthered in the MIOCENE considerably. As the time went on and the other equine traits were evolved and the folds became complex until the highly convoluted condition of modern EQUUS had been acquired. It should be noticed that the browsers did not immediately die out after the advent of the grazers, but persisted into the Pliocene. Furthermore, contrary to the general principles of evolution, the main body of the evolution occurred in North America, which was probably largely tropical or subtropical, at least into the Miocene period, rather than in the equally warm extents of Eurasia. On the latter continent, the several genera that occasionally arrived from the Newer World did undergo evolution and develop distinctive genera, but they differed from the North American representatives only in minor ways, and in each case become extinct without leaving descendant forms. Similarly, the several branches that reached South America during the Pliocene and again in the Pleistocene radiated briefly before undergoing extinction. Perhaps the oddest event of all, however, is that the entire American line became extinct in recent times, where in cold world wild asses, horses and zebras still persist. Some of the first perissodactyls were horses, no larger than the terrier admittedly, but the first in which had came to be regarded as the evolutionary classes, that is Simpson 1961. Major changes may be observed during the history of the horses as a reduction in the number of toes from 4 in the front and 3 in the back in the first horses, that is Hyracotherium, to 3 in MESOHIPPUS and 1 in PLIOCENE, and independently in modern EQUUS, and a deepening of the cheek teeth from small leaf crushing molars to deep rooted grass grinders of the modern horses. The changes in the limb structures and teeth were linked to the overall increase in body size that occurred during the horse evolution. The changes have been explained by major environment changes that took place during the late Oligocene and early Miocene in the spread of the grasslands in North America. Early horses such as Hyracotherium, MESOHIPPUS and PARAHIPPUS were browsers that fed on the leaves and bushes and low trees. As the forest retreated and the grasslands spread, new horse lineages such as MESOHIPPUS and Hipparion stepped out onto the plains, and out their reinforced molars worked. This radiation happened relatively rapidly about 17 to 15 million years ago, that is mid-Miocene in the North America, and further later elsewhere as the Hipparion migrated into the Old World. The late Miocene, that is 10 million years ago, and eventually in the South America when Hipparion entered 3.5 million years ago during the Great American Interchange. Hyracotherium was a cryptic animal that escaped predators by being small and bending into the background. On the open grasslands, the Miocene horses evolved long limbs and perhaps to save the energy cost in the locomotion. Long legs and single hooves allowed the later horses to achieve greater speeds. Long limbs were not needed to escape predators because wolf-like carnivores evolved only in the latest tertiary. The dental changes were brought on by the major switch in diet from leaves to grasses. The grasses contains a high proportion of silica, is very abrasive, and feeding on the grasses also introduces grit in the mouth. Grazers need high crown teeth and they last for long time, and they usually have complex enfoldings of enamel and dentine to provide a better grinding surfaces. The story of the horses has become a textbook example of progressive evolution or orthogenesis, or the trend, as there seems to be a clear-cut one-way line change from the small leaf-eating Hyracotherium to the large grazing EQUUS. But there is no evidence to uniform changes into the pattern of the evolution, as rather more complex as might the first seems. There was no single line of evolution from Hyracotherium to EQUUS, and many side lines or they branched off into the Oligocene to Miocene. Thank you very much.